A lot of the times people get confused about what a relation is and what a function is. And sometimes people think they're always the same, and other times they think they're completely different things. And the real answer is it's kind of in between those. Not every relation is a function, but every single function is a relation. It's just a very specific type of relation. A relation in general is a set of ordered pairs, or you could say inputs and outputs, or x values and y values. And the thing that is open about relations is that for every x value, you can have multiple y values or multiple outputs. It's not restrictive in that sense. However, for a function, it is a specific type of relation whereby every x value has a specific and different y value. For example, if I have an input of 1 or an x value of 1, if it's just a relation in a general sense, right, the relationship between that x being 1 and another ordered pair might be that you might have a y value of 3 or 4 or 5 for that same 1 value, and that's fine. Now, if this is a function, x at 1 would have to either be 3, 4, or 5. It can't be all 3. Otherwise, it's not a function. So x at 1 would have to be 3, and then perhaps x at 2 would have to be 4, and x at 3 would have to be 5. But you can't have more than one value, one output for every x input. And that is the difference between a relation and a function. Now, the vertical line test for any function, it doesn't matter what it is, whether it's a linear function or a quadratic function, is that if I have, let's say I've drawn a series of points and they form this line over here. Well, if I take a vertical line, so I'll do it in an orange highlighter here, and I run it against any point where that line is. So I can run it through, let's say, I'll make sure the lines are straight, so I can go through here. Or I could run it through here, or even run it through here. At each point, it doesn't matter where, it only crosses the line once. And so here, this function, the purple line, would pass the vertical line test, because remember that the very definition of a function is that for every x value, there's a specific y value. And that's what this singular intersection means. That whenever I pass through, what I'm really doing here at each orange part is I'm passing through an x value, I'm getting a distinct y value here. See? So the vertical line test is that if you draw a vertical line anywhere along the function graph and it only crosses the line or curve once, it is a function. Let's say I got another graph here, a line in green, and I want to know if that is a function, right? So f at x question mark. So I'm going to do the same thing. I'm going to perform the vertical line test. So I'll do a vertical line through here. And that passes, right? Because I can see that it just hits once over here. But let's say if I do it anywhere else. Yeah, it also passes the vertical line test over here. So this definitely passes, which means that it is a function. If your vertical line only intersects with the graph once, then it passes and your graph represents a function. So for a final example here, let's say in blue, I want to know if this represents a function. So this kind of parabola that's turned on its side. And so I'm going to do the vertical line test. So I can do one through here and one through here. I really only have to do one, but I always, encourage you to try multiple if you're unsure. And so unlike the other ones, we can see that when we draw the vertical line through any part here, it actually hits the line twice. And so therefore, for every x value, you actually have, in this case, 2 y values, which is not what the definition of function is. So this does not pass, and therefore this is not a function.